Hello students, in this video I'm going to teach you external sort. So the objective behind this lecture are, after uh, watching this video you will be able to know why we need the external sort, how a merge sort works as an external sort. Okay, so all of you know sorting is a classic problem of computer science. Why we need a sorting? After sorting, it is very easy to find out the duplicate number, duplicate data, right? And if the data is sorted, then searching becomes efficient. So that's why we need a sorting. Now consider a problem. If we need to sort a data which is of 20 GB and we have a primary memory RAM with us that is of only 1 GB, then how to sort the data? All of you know that to get any work done, that data must be in a primary memory, right? Here the primary memory size is limited, that is only 1 GB, and a data which is to be sorted, that is of 20 GB. So at a time this 20 GB data cannot be loaded into a main memory. And how to sort the data then, right? So there are two types of sorting: internal sort and external sort. Internal sort, we have already studied what is internal sort and different types of internal sorting. When a data which is to be sorted, that is loaded in a primary memory RAM, then that sorting algorithm is called as an internal sorting algorithm. Different types of internal sorting algorithms are bubble sort, insertion sort, selection sort, shell sort, etc. External sort, if a data which is to be sorted, if that is on a secondary memory hard disk, then the sorting algorithm is called as a external sort. Merge sort is the algorithm. It works as a both internal sort and external sort. In this video we are going to see how merge sort works as a external sort. Okay, here we are going to consider a two-way external sorting technique. In two-way external sorting technique, it requires three buffers. See the block diagram for that. For external sort, in a pass 1, a data is loaded according to the buffer size or the page size, RAM size. Data is loaded from a secondary memory into a primary memory. Then data is sorted by using any internal sorting algorithm. The internal sort can be a heap sort, it can be a merge sort, or it can be a quick sort, or any another algorithm. But why I have mentioned only these three algorithms? Because these three algorithms, heap sort, quick sort and merge sort, gives a better performance than other sorting algorithm. So in a pass 1, according to the RAM size, data from a secondary memory is loaded into a primary memory, that is RAM. It is sorted by using any sorting algorithm, and again that sorted data is loaded back onto the secondary memory. Now pass 2, pass 3 or pass 2 onwards, we require buffer. In two-way merge sort we require 3 buffer. Why 3 buffer? That I am going to explain now. Consider a disk, hard disk, secondary memory. A data need to be sorted according to the size of RAM, that will be loaded onto the input buffer in a main memory. In two-way merge sorting we require 3 buffer, 2 input buffer and 1 output buffer. Here I am considering all of you know how merge sort works, internal merge sort works, because the same technique, the same algorithm is going to work for the external sort algorithm also. Okay, so consider there is one input buffer, there is another input buffer, the data is loaded from a secondary memory into that input main memory buffer. And consider if we want to arrange a data in an ascending order, then a first record from a input 1 buffer will be compared with the second record from a input buffer 2. Whichever is the smaller, that will be written onto output buffer. Consider the input buffer 1 has a smaller record, so that will be loaded, that will be written on a output buffer. Next time, the next record from a input buffer 1 will be compared with the first record of input buffer 2. Again, whichever is a smaller, that will be written on an output buffer. So here we require 3 buffer. Once the output buffer is full, the data will be written back onto a secondary memory. Meanwhile, if either input buffer completes all its record and comparison, then again a next page will be loaded onto a main memory buffer. So in two-way merge sort, we require 3 buffers, 2 input buffer and 1 output buffer. Now consider one simple example for an external merge sort. A list containing 4500 records is to be sorted using a computer with an internal memory capable of sorting most 750 records. It means there are total 4500 records which are to be sorted, and the main memory size, internal memory size, is only of holding 750 records at a time. So the complete data cannot be loaded at a time into a main memory. It means here we have to use the external merge sort. The input list is maintained on a disk and has a block length of 250 records. We have available another disk that may be used as a scratchpad. Now block length of 250 record. What do you mean by this? See, even though the main memory is capable of holding 750 records, but at a time only 250 records can be read and written in a main memory. Okay, so if we want to load 750 records in a main memory from a secondary memory, so we have to use 3 blocks for that. Okay, so in the first block, first 250 records will be written into main memory, next 250 records, then next 250 records. Likewise, even though the memory RAM size is of holding 750 can hold 750 records, but we need to load 3 blocks of size 250 record. Okay, so this is the output of the pass 1. As we have seen, there are different passes, and in a pass 1 we require only 1 buffer. Okay, so a first 750 records out of 4500 records will be considered. That 750 records at a time only 250 records, like 3 blocks, will be loaded into a main memory. That will get sorted by using any internal sorting algorithm, and after sorting, that will be written back onto a second memory. Once that 750 records are sorted, we call that as a run. So first 750 records, after sorting of 750 records by any internal sorting method, that run will be loaded back onto a secondary memory. Then next 750 records from a secondary memory will be loaded on a RAM, that will be solved by using any sorting method, and again after that sorted data will be written back on a secondary memory. Likewise, for this 4500 record, there will be 6 run. So output of pass 1 is there are 6 run. Run, what do you mean by run? Run is a sorted segment, sorted data, right? Okay, so now next slide. Here we are saying the Number of passes required for this problem are 4. Okay, output of pass 1 is 6 runs that are sorted and written back onto a secondary memory. In a next pass, run 1 and run 2 will be considered to combine for a for a next segment. Likewise, run 3 and run 4 will be considered to merge it out. Run 5 and run 6 will be considered to merge it out. Okay, so run 1 and run 2. Likewise, I have explained this block diagram. Again, it will pass 2 onwards. This block diagram we have to consider while merging. Okay, see, main memory size is of only 750 records, right? So there will be 2 input buffers of size 250 record and 1 output buffer size of 250 record. So first block of run 1 that we have to consider, second block of run 2 that we have to consider while merging the record. Okay, so consider a first record in a first block of run 1 is smaller than a first record of a second run. As first record is smaller, that will be written onto a output buffer. First record of output buffer. So next time, a second record from a first block of a run 1 that will be compared with a first record of run 2. Whichever is the smaller, that will be written onto a output buffer. Once the output buffer is full, that will be written back onto a secondary memory and the output buffer will become empty. Right? So I have explained this previously also. So likewise, all the records will get compared. Whichever is smaller, that will be written into output buffer. Once the output buffer is full, that will be loaded onto a secondary memory. Likewise, all these runs will be merged to become a next run. Okay, so the output of pass 2, in a output of pass 2 we have 3 runs, right? All these 3 runs will be given as an input to a next pass. In a next pass, these first 2 runs will be considered. Again, by using this block diagram, by this technique, these 2 runs will be merged to become a next segment, next run. Okay, and in a pass 4, this run will be considered to compare with this run, and then we'll get the final output in a pass 4. Okay, here all these blocks, whenever we get the output buffer full, that output buffer is written back onto a secondary memory, right? So where will be the sorted data at the end of pass 4? Yes, at the end of pass 4, the complete sorted data is in a secondary memory, right? That's why this is the external merge sort algorithm. Okay, we'll see one more example for this. Consider this example. There are 13 records in an input file and a page size or a buffer size is capable of holding 2 records only. A very simple example. Total 13 records and a page size or buffer size is capable of storing only 2 records. Okay, so all these records, all these pages will, page by page, all these pages will be loaded into a main memory. First page will be loaded into a main memory. Any internal sort can be used and the sorted data will be written back onto a secondary memory. Likewise, all the pages will be sorted and written back onto a secondary memory. This is the output of pass 1. So see, 3 and 4 as a input will be given, sorted data, 3 and 4 written back onto a secondary memory, 6 and 2 sorted data, 2 and 6, so this page will be written back onto a secondary memory likewise. So this is the output of pass 1. In the next pass, in a pass 2, this is the output of pass 1 and that will be given as an input, right? As it is a two-way external sort merge algorithm, so at a time these two runs will be considered for merging, right? So first run and second run will be considered for a merging. So first record 3 from a first run, first record from a second run is 2, 3 and 2 will be considered, smaller is a 2, so 2 will be written onto output buffer. Next time this first record 3 and 6 will be considered, 3 is a smaller, so that will be written onto output buffer. Now as this output buffer have two records, it means the output buffer is full and that will be written back onto a secondary memory. Next record 4 and 6 will be considered, 4 is a smaller, so 4 will be written onto a output buffer, then 6 will be written onto a output buffer. Now again the output buffer is full, so that will be written back onto a secondary memory and the output buffer is empty. Likewise the third run and fourth run will be combined and so on. So this is the output of pass 2. This will be given as an input to the next pass. Okay, so in a pass 3 we have to consider this first run and second run. Again the same block diagram we have to remember, and again we have to consider 3 and 4, whichever is the smaller that will be written onto a output buffer, and likewise. So again we'll get these two runs as a output of pass 3. In a pass 4, these two runs will be considered for a merging and this is the final output. Okay, again here I am mentioning that this output, final output is loaded, is present on a secondary memory. Okay, and that's why it is a two-way external merge sort algorithm. Now if there are n number of pages, then the n number of pages in the file, then the number of passes required are scaling of log n to the base 2 plus 1, and the cost of the algorithm is 2n scaling of log n to the base 2 plus 1. Okay, all of you know that the merge sort algorithm uses divide and conquer method. Here the external merge sort algorithm also uses the same divide and conquer method, right? So here we have seen how the two-way external merge sort works, and with the help of one simple example I have explained it. Now the next point is k-way merge sort. Okay, previously it was a two-way merge sort. If the value of k is greater than and equal to 2, then we call it as a k-way merge sort. Okay, why we require a k-way merge sort algorithm? To reduce the number of passes. Okay, see the previous example, as it is a two-way merge sort example, number of passes required are 4. But if for the same example, if it is a 4-way passes or 5-way or so on, then it will reduce the number of passes. Okay, so here again there is a simple example. Consider this is the output of pass 1. So output of pass 1 is there are 16 runs. Okay, so output of pass 1, there are 16 runs, 16 sorted segments, and we have to apply external merge sort with the value of k as 4. It means first 4 segments will be considered to merge the file. Next 4 segments will be considered to merge it up. Likewise, so for the 16 runs, there will be 4 runs as the output of a pass 2. These 4 runs will be given as the input to a next pass. Okay, so third pass will have these 4 runs, and that 4 runs will be considered to combine to merge the file. Okay, so as there are 16 runs, but we are considering a 4-way merge sort algorithm, the number of passes required are only 3. So if we increase the order of k, then it reduces the number of passes. Okay, so here I have given just the introduction of k-way merge sort algorithm, right? And we have seen one simple example of two-way merge sort algorithm and how it works. Okay, in University of Pune, the question asked for a second year computer engineering student is write a short note on an external sort, and the question can be asked, some records will be given, array will be given, and we have to solve it by using a two-way, three-way, or whatever k-way merge sort algorithm, right? So likewise a question can be asked. Fine, so thank you. Here we have completed the topic external merge sort. Thank you.